Sophomore stream. In this video, we are going to discuss on these two integrals, which are commonly known as sophomore stream. We'll begin with the second integral because this one looks more nicer. We have integral from 0 to 1 x to the power minus x dx. Of course, we can deal with it directly, so we will first change into e form. So when we do e to the power ln of x to the power minus x, we can now use the property of logarithm where the exponent comes in front. With that, we have 0 to 1 e to the power minus x ln x dx. Now we can use the series of e. We can use series expansion of e. Yeah. If we use series expansion of e, we get it to be 0 to 1. Sum from n equals to 0 to infinity minus x ln x to the power n by n factorial. This is the series expansion of e to the power y. Now we can just take the constants out. So minus 1 to the power n by n factorial are just constants. We get also interested in the sum in the integral. Yeah. So since integral is linear, this can be interchanged. Sum from n equals to 0 to infinity. Integral from 0 to 1 x to the power n ln x to the power n dx. Now for this integral, we can let ln x to be y. We can just let ln x to be y. So if we let y as ln x, now we are fully dealing with this integral only. We are now just dealing with this integral and nothing more. X to the power x ln x to the power n dx. What was here? Minus n to the power n summation n equals to 0 to infinity. Okay, now for this integral, we so make a substitution y equals to ln x, and that gives us e to the power y equals to x, which gives us e to the power y dy equals to dx. And thus we have integral from minus infinity to 0. X to the power n will be now e to the power ny, and here y to the power n, and dx is just e to the power y dy. E to the power y dy, e to the power yn. Now what we can do is we can try to take it into the form of the gamma function. Yeah, we can try that. It's minus infinity to 0. So we have e to the power y times n plus 1 and y to the power 1 dy. Now I can let z as minus y to take it into the form of gamma function. So with that, we have infinity to 0. Why this happen? Infinity to 0 e to the power minus n plus 1 z times minus z to the power n and minus dz. Now we can use this negative sign to have reflection in the limits of integral. Yeah, we can do that. And if we do this, we have integral from 0 to infinity negative of 1 n plus 1 z times minus 1 to the power n z to the power n dz. Now we can use the formula, which is also using some transforms. Yeah. Okay, the formula is integral from 0 to infinity e to the power minus st by t to the power n minus 1 dt So this t is actually in the power. So e to the power minus s t to the power n dt. This is equals to gamma n by s to the power n. So we'll use this formula, and then what we can do is this will be equals to minus 1 to the power n and gamma n plus 1 by n plus 1 to the power n, to the power n plus 1. Okay, and so we have this. Now we'll substitute this back in this expression. In the expression we had minus 1 to the power n by n factorial, and the summation from n equals 0 to infinity. Okay, we'll substitute it back there. Minus 1 to the power n by n factorial, summation from n equals to 0 to infinity, and then we have minus 1 to the power n, gamma n plus 1 is just n factorial by n plus 1 to the power n plus 1. Now minus 1 to the power n and minus 1 to the power n will be minus 1 to the power 2n, so that will just be 1 to the power n, that's just 1, and these two of course cancel out, and so we have summation from n equals to infinity, that's just 1 by n plus 1 to the power n plus 1, and now we'll let n to run from 1 to infinity. Then we will have 1 by n to the power n, and that's the proof of this Sophomore's dream integral. Now we have proved this. We can continue to prove this in a similar way. Basically you will have x ln x over here, and if you have x ln x, here also you will have minus x, you will have x ln x, so there won't be such minus 1 to the power n, and if there isn't minus 1 to the power n, this minus 1 to the power n will not dissolve, so it's continue, it's exists over here as well and here as well, so that's how we get that minus 1 to the power n. And when we change from n equals to 0 to n equals to 1, the minus 1 to the power n will change into minus 1 to the power n minus 1, so that's why it exists here as well. So this is just similar integrals. Now this is one of the famous integrals and considered to be the dream of a sophomore. So it's not a dream anymore, since you know how to prove this, how high this exists. Thanks for watching. Have a good time ahead. Do enjoy our channel with some interesting integrals. Thank you.